Good evening, my fellow Americans. My name is Nathan Morrow, and I'm joined here with my fellow associate, Andrew, and we're going to talk to you today about two engineering disasters. The first of which is an electrical engineering disaster about the Apollo 1 fire. And the Apollo program was the start of a massive undertaking with the end goal of landing a man on the moon. President John F. Kennedy at the time promised that in 1961 to the American people, motivating NASA's team of engineers to work fast to accomplish his goal. The engineering of the command module of Apollo 1 was rushed, said by the crew commander Grissom. The engineering crew at NASA is used to having setbacks and delays for their aircrafts, so completing a successful command module on a strict timeline was incredibly stressful for the team. On the day of the command module test, the crew even experienced communication failure, and Grissom said, "How are we going to get to the moon if we can't talk between 2 or 3 buildings?" Then the oxygen exhaust going into the command module was pumping in at a drastically high amount of pure oxygen that set off a few master alarms while the crew was still in there for their second hour. Approximately 6 hours after the test began, Grissom announced that a fire is indeed in the cockpit. A frayed wire grounded itself with the hole to create a spark, and in the high concentrated oxygen environment, torched a nearby nylon netting and flammable foam pads. 3 minutes later, when the technicians were able to open the hatch, all 3 U.S. astronauts were found dead. The Apollo 1 fire is a testimony to safety procedures and quality control. The crew did practice an emergency escape plan, but never made it under the desired 90 seconds. Also, the command module never had enough quality control on it to fully test every electrical system on board and ensure the safety. After Apollo 1, NASA postponed all the following Saturn launches to ensure the safety of the astronauts and successfully complete the Apollo program with no further casualties. Now we are going to transition into our second engineering disaster, presented by Andrew.
PepCon disaster occurred on May 4, 1988, at a plant in Henderson, Nevada, owned by the Pacific Engineering and Production Company of Nevada. The plant produced ammonium perchlorate, a powerful oxidizer used in the solid propellant rocket boosters that were used to launch space shuttles. At around 11:30 a.m., workers were repairing a drying structure when sparks from a welding torch ignited fiberglass that made up part of the structure. The workers attempted to extinguish the fire, but it grew quickly due to the ammonium perchlorate residue that covered the drying structure. Soon enough, a fire spread to a group of 55-gallon drums of ammonium perchlorate nearby, and at 11:53 a.m., multiple drums exploded in a 100-foot wide fireball. The resulting shockwaves shattered the windows of fire trucks on their way to the plant. The fire units headed back away from the plant, fearing another explosion. 4 minutes later, the fire reached the storage area, which held 5,000-pound shipping containers filled with ammonium perchlorate, and an even larger explosion occurred. Not much fuel remained after the second major explosion, and the fire began to die out rapidly. Fortunately, only 2 of the plant's 77 employees were killed. Many employees were leaving for their lunch break around the time when the fire began, and were able to drive or run to safety. However, 372 people were injured, and the explosions caused over $100 million in damage. Looking back, there were multiple factors that led to this disaster. First of all, although NASA had halted the Space Shuttle program after the Challenger explosion in 1986, PepCon did not reduce production of ammonium perchlorate, so a large stockpile was being stored at the plant. It is estimated that 4,000 tons of ammonium perchlorate were stored at the plant on the day of the disaster. Moreover, ammonium perchlorate residue was present throughout the plant due to lack of regular cleaning. The facility was only cleaned thoroughly prior to plant inspections. Additionally, all of PepCon's storage drums, containers, and bags contained oxidizable material. And lastly, neither a fire alarm or a sprinkler system was installed despite previous small fires, which were quickly extinguished in the same building.